Yeah, nice to see everyone. Glad we all kind of made it on the other side of this heat wave up here in Vancouver. So that was rough. I know I definitely had some trouble thinking here and there. Putting together some complex thoughts was a little rough.
Yeah.
So I kind of just go right into my quick report here. I migrated some of the analytic functions from SimPEG into GeoAna and kind of added some more tests to make sure they were correct. And Dieter and I were chatting about like signs and things, and making sure everything made sense there as well. Um, but it looks good. Also, considering that we've been having a decent amount of problems recently with the Mkl libraries or the Paradiso solver in there and like linking to it with the PyMkl, I wrote up a quick Cython wrapper for it for the Paradiso solver. With the goal of it being a little bit more rigorously built against the Mkl version, and that it like a little bit more. It should always properly link up when you have the conda build. Like it should always work properly. So it's built against it in the same way that Intel has their own conda recipes for things like if you haven't found it, there's this Mkl Service package that exposes a lot of the underlying control functions for Mkl. Things like setting the number of threads to use. You can set threads used for individual processes. Like if you wanted to limit the number of threads that the FFT routines used, you could do that specifically. There's a bunch of other things like, okay, you can get versions from that as well. But I was able to take keys from what they did there to figure out like how they were properly linking to them, like their own Mkl library. Because I mean, obviously they should know how to do it, right? They're the ones that made it. So I just kind of followed along with those steps, and I sent it to a couple people to see if they could get it to build locally, which they, John and Dom were able to get it installed pretty easily on Windows. I know I've installed it on my Mac or my Windows machine as well, and Ubuntu's good. And I'm doing some GitHub tests with all 3 operating systems, and it builds fine on there. So that's a good thing. Fortunately, though, if you're installing it from Conda, like once we get it up there, the user doesn't have to build it, right? It's built. Conda forward servers build it for themselves, and then it's already properly linked up with how Conda would expect it to be linked, right? The same way that all those other things are. So it's just a little bit more rigorous in how it's handling linking to the Mkl. And then that should make us not have to.
Does anyone know if there will eventually be a newer version of it in Mkl? Is there a plan, or they don't plan to release anything open?
A newer version of Paradiso?
Yes.
I have no idea. I doubt it. I have a feeling like that Paradiso project doesn't want to sell it to Intel anymore.
Yeah, okay.
But I also have not played with that Paradiso project at all.
Me neither, no. Yeah, I just thought maybe they do it like always. If they have a stable release that is, I don't know, 5 years old, they might drop it out, but maybe not.
Oh, yeah, you never know.
Joe, if like because Mkl is a big library, and there are a lot of actually numerical kind of recipes that we could potentially, like a kind of something like a matrix vector product, they got actually kind of special functions. Is that something that we can actually use in our end as well? Or most of them are actually in NumPy, so they actually use the Mkl. What's the situation?
So with Conda, NumPy is built usually with Mkl as the blast, like the
I see.
library
It's
behind
already
it.
there. Gotcha.
The only thing that I think we could take advantage of with Mkl is they have a few sparse matrix vector routines that could potentially speed up like those operations, like sparse matrix times a vector, compared to how they're implemented in SciPy. The SciPy, they have their own simple implementations of them. Like, I mean, it's pretty fast. There's not too much you can do as far as optimizing a sparse matrix times a vector multiplication, but I imagine the Mkl libraries might be a little bit better optimized for the targeted processors. That's the only thing that
But for dense operation, like what NumPy is actually pretty much optimized.
and NumPy is probably already using that.
Right. Got it.
I had a, before I used Numba with EMPyMod, I did sometimes some benchmarking with running it with and without MKL. And well, all my functions are using NumPy and SciPy. And there was quite a difference here, whether you use it or not. It always depends which functions you use. But so yeah, NumPy definitely makes use of it already. So I don't know how much you could gain. Just what NumPy often does is they do some checks, finite tests and stuff like this, which sometimes you could speed up. But
yeah, like I at this point with this, I think we probably need to take a step away from that PyMKL library because it's essentially dead and they're not maintaining it or updating it with the new items. So I may need to do this. I think we probably need to have a discussion about where it should live, whether it lives on its own or it lives as part of PyMat solver. I don't know. I've been thinking about it a little bit, and I guess for me it kind of makes sense that it would be somewhat separate, considered just like meant to do this Paradiso interface. And then PyMat solver could certainly rely on it the same way that PyMKL does.
Right. If the only purpose is actually handling Paradiso, then yeah. I think it's probably fine in PyMat's solver if that's the only case. Like if there has any other general purposes, maybe it's worthwhile to make a separate thing.
Yeah, my only concern with that was adding like that compiled part of it to the PyMat solver. That was my only like hesitation from putting it with PyMat solver.
now, with by Googling Python and Paradiso, there seems since PyMat solver was built, I think there are quite a few projects that wrap Paradiso. I don't know if it could be possible to use another one.
Yeah, I was looking at some of them. Most of them were just dealing with like the real matrices. They didn't have any complex support or anything.
Okay.
So that's why I was like, I just threw a Python wrapper together. It was pretty robust and
cool.
Yeah. I can send. I still need to like test it against things to make sure it doesn't break anywhere too hard, and that its performance is probably on par with what we had before. Temporarily, I'm calling it PyDiso.
Got a good ring to it.
That's my quick report. So, like I said, I wasn't doing anything. I didn't have too much complex thought outside of just implementing a wrapper or something. Anyone else have any updates over the week? Dieter, I think, if you would like to lead off.
Yes, I don't know who saw the. I think Tibor reacted to it and Lindsay. It came up in a Swang meeting recently about how long do meeting recordings live on the internet? How long should they live? And I thought it's maybe a good discussion to have with the government policy. Yeah, it was raised because of the justified concern that things can be taken out of place 5 years down the line or something. How long should everything be online? Not everybody being the same easy going about it, something like this. So I don't know what other people think. Lindsay chipped in, and then we said maybe we could have after a while, have them unlisted, so they're still on YouTube, but you need to have the direct link, and then after another while, completely remove them from the public view. Yeah, what do others think?
Well, in some ways, the stuff that we talk about in our meetings, I guess there's like an intent to finish the projects we're talking about, let's say within 6 months. So that could be kind of an upper limit for that. At a certain point, it doesn't necessarily seem like it's useful to have videos talking about things that have been like merged into master, release, documented. So at the very least, we could probably delete them after 6 months, or not make them available freely after 6 months.
Who's gonna watch all videos anyway?
Exactly. I mean, either you follow up on a meeting within a week or two, or you probably don't.
That's another way to look at it too.
Yeah.
I don't think you're going to look up what we did 3 weeks ago and go, oh, yeah.
Yeah.
What Lindsay
I
said,
think it is
maybe
like,
yeah, go ahead, sorry.
I was just gonna say, yeah, like if you like unlisted or like put it private after a year, that's probably like a conservative position, and but also considerate. So I have no problem with that. And like it's true that also like those like right to be forgotten laws on internet varies from one country to another. But yeah, I think there is no. I don't feel a need to archive everything forever, indeed, or at least not having it public forever.
I think what Lindsay said in the chat there for maybe having it a bit longer, I think she linked in the governance to the meetings where we decided it. So then there is a link, but that would also, because it's the direct link, then it would still work if it's unlisted. So you cannot Google it anymore,
Yeah.
but you can still find it. So yeah. Yeah, I just
And maybe
thought
there
I'd
are
bring it
some,
up.
yeah, and maybe there are some meetings that are worth keeping longer. Like some meetings we do, like it was actually someone doing a presentation, so that can probably stays up longer. Or like if like the meeting we had about governance too, or where we're really putting the groundwork for the governance, is like probably one that's worth keeping longer. But somewhere it's just like week to week discussion, or like more casual. Yeah, after 6 months or a year, it's probably fine if it's at least unlisted.
I think that's perfectly fine. I like the idea of having them just kind of like, we don't need to keep records of every conversation we've had, 2 years ago.
All my bonehead comments. Yeah, can delete those. Hey, I don't know. Just a thought like this. I don't know if it'd be possible to just convert them to text. If we could query after this, ideas or topics that were raised, it would be easier than if it was on videos, right? If we just, I don't know if it's possible to use YouTube to.
Yeah, it's possible. I've actually used it. Like, is that YouTube can generate automatic subtitles,
captions,
and they're
right.
Yeah, and they're not bad. They're like the generated ones are not bad. So, just an example. So, I did my training of my PhD defense with the SimPEG group. So that's one presentation that I was thinking, for example, that I would like to keep that one up as long as possible. But one thing that I did was that after that training, and to prepare the real one, I was actually able to download the automatic captions, and I actually use that automatic caption to see like, okay, here is what I said and what I forgot, etc. But yeah, so you can download the automatic caption on any videos, and that's so like the text search should be actually fairly easy to implement.
But it wouldn't have the names, right? Like in recording meetings, you wouldn't see who said what.
No, you would
I don't
just have
think
like
yeah.
the audio.
Yeah.
Like it will not say like this person is speaking, because yeah, YouTube has no idea about that.
Yeah, that would be my only comment, is that, you know, hey, we're actually not even capturing it now, all right? And we're kind of, maybe someone said something intelligent and a good idea, but we're just losing it because whatever, it's piled under more videos. If there was a way to be able to capture that, but I don't know. I don't have time to work on it either.
In our notes documents, right?
Yeah, can
Maybe.
you note that, Joe? Dom just volunteered, so that's fine.
Yeah. If it wasn't remembered, maybe it was not worth remembering. Maybe it's okay.
Or if it's important, it's gonna come up later again.
Yeah, someone else is gonna rethink the same idea and it's gonna come back. Yeah, exactly.
Dieter, did you open up it should probably be something on the governance thing or the community? Like,
Yeah.
hey, we propose.
Yes, I can do that, like an issue in the governance, or where do we have that?
When we're like, oh, we propose doing it like, oh, within a year or something, that videos are just publicly, they're still available, but unlisted. And then they go away after so long. Unless like you decide otherwise for special presentations or.
Yes. Yeah,
At least
we'll do that.
It'll be a good thing.
Then what else did I have? I worked on the adjoint state with Sogi, and props to him. So it works fine now in EMG3D, at least for electric receivers. So I'm looking forward to what Sogi will do with it in the near future. But it's for me, it was an amazing insight with the whole adjoint to see, even though the gradient was pretty good before, if you compared it to finite difference, if you don't do the exact adjoint, it's still different in some ways. It's kind of fascinating. Because yeah, even though we got the receiver response more accurate because we couldn't do the exact adjoint of this, the gradient was worse. So we have to get the receiver response less accurate with a linear interpolation to become the better gradient, which is kind of counterintuitive, but yeah, it was an interesting ride. Yeah, that's it from me, I think. Do I have anything else?
I see Lindsay has posted a few things. I'm just going to say them here as well. She's added a new issues on the community repo, one about the publication listing, another about listing the institutional partners, and another minor one on the formats of the file, whether it's Markdown or RST. Institutional, I believe we'll probably have to deal with like what do we consider an institutional partner, what the benefits, drawbacks, things like that. What did they get out of it? What did we get out of it? What we're expecting. So please take a look and read over those. Devin has added on here.
Yeah, so I guess I got a few things. Obviously, I've been doing some work on the doc strings, but whether or not it's in this meeting or if some of you have some time just afterwards, I would like to maybe briefly show you what I've done and get some comments and some feedback. And I've done one example doc string of how I want to document differential operators on different meshes. And I'd really just like to nail down what we think is the most important information, or maybe like I don't know what kind of visual representation we'd like on this. So it's just, I don't think it needs to take a really long time, but I think just getting a few people's perspectives on it and maybe deciding collectively kind of like a direction would be really useful for me. So, I mean, I've gone through documenting the utilities and all of the basic properties and methods for all of these meshes and given examples and stuff, but now the differential operators and that kind of stuff are, yeah, we need to come up with a bit of a plan. Otherwise, it's just gonna maybe not be done very efficiently. So yeah, does anyone have time just after this meeting? If it's relatively short, maybe from like, I don't know, up until noon or something?
Yeah, do that. As soon as we're finished up with quick reports, we can go back through and look at them.
Yeah, that would be great. We could just kind of stay on the channel and I could screen share. The other thing that I was working on, because I had a little bit of time, was this this EM issue with rings, right? We all know you got the sensitivity, and if you've got a very compact body, it's going to recover a ring shape. And I was just trying to generate a really small scale, simple example in SimPEG that I could use to play around with. And I realized that we don't have we're not applying a preconditioner when we solve the Gauss-Newton system. I don't think we're applying a preconditioner to that. It's basically, my example is crazy, crazy slow. I've only got about 30,000 cells and 49 stations and a few frequencies. And each time I try and solve that problem, it's like 2 hours. So yeah, I looked in. We have a Jacobi preconditioner for linear problems that's very easy to construct, but we don't have one for the frequency domain or time domain. And I'm wondering if this is something that's being put in when the MT stuff is being developed.
Yeah, if you're on the tiled simulations branch, because now we're forming J, we have Jacobi. So you, if you switch to that branch, you'll be able to have access to JTJ diag. That's what you need, right? JTJ diag.
Yeah, so I mean, is that automatically been put into how you would solve the problem? Is that something I have to call as a directive, like update preconditioner? Like, how do I implement that?
Yeah, but there's an example. Look at the, I think there's an FEM example in there.
Okay, so tiled simulation branch.
Yeah, and it needs to be, right now we haven't touched time domain. I mean, if you're really keen and want to start working on updating, doing the exact same implementation that we did for frequency to time, that would be definitely useful.
Okay, let's see. I'm running some stuff that's going to take a few days on my current branch, but I will go back to that. So that example, is that just in the examples gallery, or did you put it in as a tutorial?
It's in the examples, isn't it? Or under examples, right under SimPEG?
Okay, so it's in the examples gallery. It's in the,
Oh,
okay.
I don't know what that's, yeah, that's called gallery.
All right, that would be fun to play around with. Yeah, and then apart from the doc strings, I mean, one small scale project I could kind of do pretty quickly is working on the IOs that connect SimPEG to UBC. I don't know if anyone would find that particularly interesting, but we don't exactly have that. And I know we can write a lot of things out to some compact file formats, but it is nice to be able to write out a file that maybe isn't as compact, but actually lets you see the organization of the data and see the numbers. So does that kind of make sense to you guys? I'm not sure, maybe with like, I think you can write out to JSON or something like that. So you can write out to these compact, easy to use file formats, but if you double click and open it, you don't really see, oh, here's my receiver, here's the location. It might be nice just to have that, even though it's not necessarily sophisticated. So yeah, I like the idea of having the link between the UBC and the SimPEG codes. I find that pretty handy. So I might take a stab at creating something for that.
Yeah, I would say, you know, be careful, because you might start creating a new file format that no one's going to want to use. Just look around to see what's there, right? Because
oh, well, I'm not going to invent my own file format. It's going to be directly UBC to SimPEG, right? And one of the benefits of this is with these code validations that we're doing, being able to pretty easily go and construct a mesh in a survey in using one of the coding packages, then just outputting it, loading it into SimPEG and rerunning it. It's gonna make life a lot easier.
yeah, I hear you, but again, like the number of UBC users, UBC EM users that are going to use SimPEGs is nil, right? It's just going to be you. Very few people are going to do that conversion, because those file formats are, you know, hopefully everybody starts using SimPEG in the future, and then the UBC codes are just deprecated. And those file formats are such a pain in the ass to deal with. I don't know if it's really worth your time to really create IOs for all those files. I don't know. That's just my opinion, because we're doing the same thing with GIF tools, right? I mean,
Yeah,
spend
no,
so much time customizing GIF tools to read and write those files, and no one using them. It's so frustrating.
Yeah, it is a good point. I'm definitely not, I don't want to invent some kind of new file format for that. Yeah, it's something to think about, because I do agree with you that the people are either using GIF tools in GeoAnalyst, and those people aren't really trying to then start learning SimPEG. They want to either click buttons, or they're more coding minded and just using SimPEG anyway.
Maybe just use GIF tools to convert it to a matrix form, you know, and then after this, take it up by Python or something. I don't know.
Okay, it would still be nice to have some kind of IO that you'd actually be able. Maybe there'd be like a, I don't know, verbose IO or something like that, where you could write out and see it. I still think people will want to open a file and see what's in it, even if it's not the most compact and efficient.
But I mean, if you have HDF5, it's even compact, efficient, and you can still open it and see it.
Okay, I'm not super familiar with that, but
you just have to download the viewer, but it's for free. So
okay,
and it's, for instance, people will know it because like the newest, not even the newest, all the recent version of mat files from MATLAB are also HDF5 under the hood, and I think many things are HDF5 files. I think.
Okay, yeah, I've seen those get kind of read in and read out for various things I worked on, but I haven't played with them specifically. But that might be a pretty good solution to this.
Then with Dom, you have the master in the house, so he can explain you everything about HDF5 files.
Yeah, it's fully customizable, but the problem is that, you know, EM surveys are complicated. You need to store so much metadata and then connections between things. Like just writing the format to, yeah, anyway.
No, I just meant if you wanna, if just looking at it is the thing, then nothing speaks against HDF5.
No, yeah, or JSON for that matter, right?
JSON, but then it becomes very quick huge with EM.
True.
I mean,
fair,
huge.
Fair. Yeah. At least it's compressed. Yeah, HDF5 is compressed.
Yeah, I mean, it was pretty useful doing for the potential fields and for DCIP to replicate, because those are codes that a lot of people use, but people aren't really using the EM ones.
Yeah, and there's not that many things you need to store, right? It's basically XYZ with data next to it. That's pretty darn easy. But yeah, time domain, you need to store transmitter, receiver configurations, the loops, the waveform, orientation of the loops. Like, it adds up.
the file
Okay.
structure in the HDF5s too. I've been trying to convert our databases to HDF5, and they explode up just because of the way because it's like there's a reading, then there's a dipole, and then there's like what angles, all those certain dipoles, and just the way that you do the path, it goes from like 500 megabytes to like 2 gigs. It's crazy. But again, it's just all that metadata. You have to know exactly what everything is doing when you add the acquisition. So, but it's worth it, I'd say, because, oh man, they're fast access and super nice.
Are you compressing?
I'm compressing what I can. It's just
Yeah.
like, we don't really have that big of, like, when you think of it, it's more of the path that's more important. Otherwise, the big data you're actually recording on a dipole is just either a time series that can be compressed or just a decay. So it's
Yeah. But the hierarchy is hard.
yeah.
So hypothetically then, somebody comes to you with a data file, some kind of, let's say, text file that has all the information or all the locations of things in a survey. And then you have the report so you can figure out the loop size and orientation. We should have ideally we should have a straightforward way to be able to load that into SimPEG so that you can start building stuff.
But there will be a million formats.
Yeah.
Yeah, in a practical sense, that it seems like it's not very worthwhile to figure out a general format of EM data, because it's actually not that useful, because at the end, nobody will follow that. And then it'll through a very different types of format depending upon whatever survey, even if you do the same survey, but depending upon the company who's running the survey, they may have completely different format. So
Even within the same company.
yeah, even the same company. So my guess is like, I don't know, something maybe useful having in SimPEG side about something like specific maybe. So because you may do a specific test of, I don't know, if you're doing an airborne EM, then having something like that might be at least useful and then maybe used, because if that's not too specific, it's probably not used, I guess. I think that's what's happening, maybe Mac and DC. It's quite specific, and it's actually a single format. It's pretty simple. So for instance, if you do an airborne EM, now I think it's actually quite simple, for instance, or let's say CSAMT or whatever specific survey, then that may be useful. And once you got that, you can potentially generalize at one point, but I think starting from something specific and just making it work, and that at least like could be used. So just a thought.
Yeah, but I guess what I'm hearing is just the file formats being used for EM are so widely varied. There isn't going to be like, we can't create a nice simple function that's like a general IO for that. And so in the end, I guess the onus is on the user to script up something that will load their particular format. And if that's the case, like that's just life. Yeah.
That's my opinion is. The only thing that I would add is that if you want to do something as far as writing out our information to files, it would be probably better served if we worked on serialization for them, to make sure they serialize properly.
Yeah, we already have that. I mean, if you've got 2 SimPEG users and you created something in SimPEG and you want to share it with another SimPEG user, just use serialize to output it and give it to them. That's way better.
And my point is, though, is I'm not sure if they're all properly implemented right now, like if it handles it properly. So it could be a thing to check, like serialize and deserialize on every object like that to make sure it happens. That's something I don't think, like, it tentatively supports it, but I don't think it works properly right now.
Okay. Yeah, I thought that would have been part of the tests.
Unfortunately not. Like, I'm pretty sure everything everything will serialize, but I don't think they all deserialize properly, potentially.
So they should be all unit tested, I guess. All the serializers.
Yeah.
Okay. Have you guys written anything for like the EDI format for MT?
There's
Because that's
some,
quite
there are
standard.
some reader and writers, I think, that we had created for it. I think they're hidden somewhere in the MT folder.
Yeah, there's something there. I made a few modifications because it was using a really heavy, like a lat long converter library. It was using like GDAL when I just lightened it up using it UTM. But yeah, it seems to be quite functioning. I believe I've been using it when I have EDI files.
Yeah, I mean, I guess even if it's not, yeah, even if we don't have plans to implement stuff like that, I guess the community would tell us if there was something that says, hey, a lot of us are doing this. Is there a way to yada, yada, yada?
Our MT guy at Dias, he's been involved with the community quite well, and they're changing. They're going from EDI files to HDF as well, or HD5.
Okay.
They've already started to sketch it out, but I don't think there's anything official yet. But yeah, if you want some more information, I could try and get something from him sent to you.
Yeah, I was just trying to find something small to work on if the docstring stuff stalls a bit.
Pick an issue. We have 1,000.
Good point.
Any of them.
Devin, I would, I think the most value you would get if SimPEG would very detailed describe how our stuff is getting serialized and stored. So everybody who would get something into it would know how to write a file that can be read by SimPEG. That is the much better path than trying to make loaders for particular files, unless there is a real request. But if you can really describe how we serialize our stuff, then anybody could write a file that can be read by SimPEG, and that's much more worthwhile, I think.
Yeah, actually, that's a really good point, Dieter.
Yeah. Like the discretized tensor mesh, for instance, I don't think it's a docs, but it would just need the age, it would need the origin, I think like 3 things. So everybody could write a file that then could be read by SimPEG, right? If it's documented. So.
Yeah.
That's an
Good
easy
idea.
example. I guess other things are more difficult, but still, I think it would be the most valuable thing.
Yeah, it's a great idea.
Yeah, but that's basically it for me.
Cool. Okay. John, I see you got a few things there, and then Soggy after that.
Yeah, I don't have too much productive stuff to report on. Just started throwing some bigger problems at the parallelization and for the DC problem. And yeah, my MPI is blowing up. It can only handle 2 gigs or yeah, I don't know. I haven't quite figured out the error exactly, but as soon as you throw a big problem at it, it can't distribute it. It can't scatter it. So I went back to the Dask a little bit and was just playing around with it locally because we've been running the MT locally, and that I can distinctively see that they're running in parallel. But for some reason, sometimes the DC, sometimes it'll start up and it'll run them parallel, but then sometimes I'm finding that they're staggered a bit and it's almost like they're sequential. But I've kind of combated that a little bit. I found a way to assign the affinity using Dask, pretty much the same way as I did with multiprocessing. It's just like a operating system or an OS library or module. And yeah, when I first looked at it, yeah, Dask isn't actually setting affinities. So it's not telling which task to go to what core. It just kind of tells it, hey, just access it and whatever one's free, take it. But if I find I can improve it if I can tell them what task where to go. And that seems to be improving for locally running anyways.
Isn't that the nanny? Sorry, John. Isn't it the nanny that you're starting looking into, or is that different?
I haven't got in. That was what I was going to do today. The nanny kind of is under the hood of a worker anyways. But yeah, I think you can do a little bit more work with the nanny. But yesterday, yeah, I was going to try the nanny today, but I was trying scatter because Dask has a scatter option as well. But yeah, I quickly learned that that is no good. The overhead is enormous. It's crazy.
So depends what you scatter though, right? Because you want to scatter things that are permanent, but
Yeah, that's true. Yeah, if I was just scattering like the objective function or like just the misfits, and yeah, that
Oh no,
one,
that's bad. Yeah.
yeah, that one was bad. That was just, yeah. If you got like solid numbers and things to go, then it's all right. But yeah, it's not like MPI. MPI has a good time scattering those at small problems, but as soon as you get to like a 6 million cell problem, it's, yeah, toast. Even if you
Yeah, you
have
just want to scatter vectors, right? You don't want to scatter objects, I think. Yeah.
So yeah, I'm looking at I don't know. I don't know if scatter, if I try and restructure everything just to scatter vectors, if it's worth it. But yeah, we'll see. I'm having pretty good luck with assigning the affinities within the DAS tasks. That seems to be doing a good trick. But it's essentially doing what if you had a cluster. It's just telling on the computer which ones to go to. Whereas if you have DAS on the cluster, you're pretty much telling it that computer is yours, and then you are having everything in parallel. So it's just kind of the local implementation that's a bit of an issue.
I see. Yeah.
But yeah, I've been sticking my head in that all week. So those 5 days went by pretty quick, or 7 days went by quick.
That's going to be important for everybody because scheduling tasks, we're not, yeah, as you said, we're kind of throwing everything at it right now, but we have to be more careful. Like you do this, and then don't start anything else until you're done this part, right?
Yeah.
Otherwise, we have too many instances of parties when that starts kicking around.
Yeah, and then it's 2 different kind of modules too under OS for Windows and for Linux. But you can do it for both of them. So you would just have to have a check to see, oh, what my operating system is, and then it would implement the right thing. So there would have to be, there's 2 different ones, but you can still make it general. You can add it in.
So John,
Yeah.
are you what is the connection with MPI and desk? Are you using separately or?
Yeah, I was doing 2 separately. I was building, like Dom and I were working with Dask, and then I was playing around with MPI. And MPI I was finding was giving me better performance on a cluster. However, it just, yeah, as soon as you throw a big problem at it, it actually fails, which is kind of surprising. I guess most of the MPI I've ever really seen used is on 2D MT inversion and stuff, but I don't know. It seems strange. And I've looked around, and there's like an addition to MPI, or MPI that's called Big MPI, and it says that it's supposed to do big ones. It kind of does what DAS does. It just chunks everything. However, I tried it, and it just gave me the same error output that MPI was giving me, that it's too big. So I don't know if it says it was using Big MPI, but yeah, I don't know. It just seems like it's a dead end right now. So I'm gonna jump back.
Yeah, so John, I'd be curious to see how you're implementing this with MPI.
Oh yeah, actually I'll shoot you my my repository. I have it on my forked repo.
Because I'm curious where you're breaking things up and what's getting sent around. Because like for me, the way I would imagine doing it with MPI, right? Like I would just break things up based off of like sources and receivers. I wouldn't send around any J matrices. I wouldn't send around any, like the only thing I would send around was maybe like I'd send a vector when it has to get multiplied or something, right?
Yeah, I think that's where it's going a little bit wrong, because I'm scattering the simulations so that the simulations go on to each cluster node, and then that all its information has to do with the derivatives, to do the depreds.
Yeah.
Yeah.
I see.
So that might be why, like maybe it is, I have to break everything down to scattering vectors. You can't just, scatter a whole object, I guess.
Yeah, that's rough. Like it's, so let me see, I'll take a look at it and see what I can point out and what jumps out to me.
Okay, yeah, I'll point you at what lines. It's just in get depreds under the inversion problem .py.
Yeah, not moving the mesh around would probably help a lot too, if we can just keep the vectors.
What else? Soggy? Yeah, a little soggy.
Yeah, I don't have any technical update, but we submitted the HU session for in your Surface Geophysics about open source. I think what was the title? yeah, open source software for near surface geophysics and its application. So yeah, hope you guys submit some abstract so I can see you all there. And if you have a good, so I need to have two invited speakers. So somebody who in a high profile, I don't know, doing some cool things. So if you guys have any suggestion, please let me know. That would be very helpful.
I'm sure Craig would love to be there. He loves AGU.
I'll
Okay. Anything else? If not, we can like to see some of the, and have some of Devin show some of that docstring stuff and documentation that he's been building.
I'm gonna go back to work. See you guys. Have a good day.
Same here. Sorry, good.
Yeah, if you guys need to head out, like there's nothing stopping you.
Sure.
Yeah.
Yeah, see you guys.
Just need share screen powers whenever you can.
There you go.
Yeah, so this is kind of like this is the landing page for the API reference. Most of it was pretty structured based on what Joe had there before. But we have our, our mesh classes, and then there'll be sort of a kind of like a base. So base meshes, a place where we have the discrete operators, and then mix-ins. I guess this was a set of classes for like interacting with VTK, or kind of interacting with external packages. So if we want to take something that's SimPEG formatted and then reorder it for something else, that was a place to do it. And then we have all those utilities. But I guess the stuff that I'm most interested in getting feedback on is stuff for operators. So here we go. So I decided to do a little bit of a prototype one, just the face divergence on a tensor mesh. So yeah, we'd have kind of our one sentence descriptor that would show up in the big list of properties for that particular mesh or that particular class. And then the returns, everything is linked. And it would give you the dimensions of this, a little bit of an explanation, and then something kind of brief about the operator. So in this case, it's a second order numerical divergence operator. It maps from the faces to cell centered. And once it's constructed, it is stored permanently as a property of the mesh. So I don't know if we want to elaborate too much on this description, but we do have a space under notes where we can provide some mathematical background if we want to. So that's some questions I have, is how much of this math do we want to put in the main description, or do we even want to bother? That stuff is sort of questions I have. And then below we can put in some kind of example. And for these operators, it's nice to have some visual representation. And so below, I just, there's a script that will basically just show the mapping. So it's going to map from the green, the faces, and it gives a number of the index of this value in the original vector, and then tells you where it's mapping in red at cell centers, and then gives you something about the structure of that the resulting matrix. So this one I think is pretty straightforward, and I wanted to use this as a template for other ones. But before I start going nuts, I wanted to get some feedback.
Well, I mean, it's definitely looking pretty good. I like how it I think the details at the beginning of it are great. The I think the Q is a little abstract. And defining it like this is maybe a little bit abstract. So it's like, I guess the way I would approach it is, I need to write it on something and show, but I would look, okay, this face divergence matrix, like we've talked about before, like for each cell, it takes the sum of the values on the boundaries or on the faces dotted with their normals, right? And then adds them together by the area or something like that, or multiplied by the area, whatever it is.
Yeah. Yeah. I mean, in the end, the first half of it, like this is kind of the important part. That's just saying it's a second order divergence operator. It's going to.
Yep.
Yeah.
So.
Okay.
I would like, I don't think we need it explicitly like, okay, it's exactly diag V inverse Q diag S. Just, I think it'd be enough to just represent it in terms of like, okay, it's a sum, like for each cell I, sum the faces dotted with their thing. Like this is what it is doing for each cell.
Yeah, I thought about doing that, and I didn't want to make it, really long. And then a lot of those details I decided to put in the tutorials. So that was, this is kind of like, this is the information that you need to be able to implement this and know what you're doing. But the details about like which faces I, J, K, we did kind of cover that in the tutorials. So I'm less inclined to do that on this.
Right. I don't necessarily mean like, okay, it doesn't have to be IJK for anything, just kind of a general thing like, oh, sum the faces, like sum over faces for cell I, right? Sum over faces.
Yeah. Okay.
At least I don't know, that kind of, at least like representing them as their like most fundamental thing of what it's actually doing. Possibly, I don't know. Because even like looking at, okay, like diag V inverse Q times diag S, like I know what it's doing. I'm sure like some of us here know what it's doing, but it's for someone else looking at it, they'd be like, what, how is this doing the divergence?
Yeah, and I wanted to include something like that where there was kind of that fundamental equation where it's like X face minus X face over the cell dimension plus Y face minus Y face over the Y dimension plus, I wanted to put that in, but in a way that wasn't going to lead to more math or more explanation than is necessary.
Right, that's what I was like, just, it's, I would say do it as like the, it's a set, what is it, the Gaussian form of it, or not, whatever, not Gaussian, the integral form of it.
Yeah, integral form.
Like, I think that is pretty clear, and that's about what it's doing here. Like, that's basically what it's doing here, right? So I think that is just, it's this operator.
Can you remind me of that? I'm not sure. I'm not following.
I was trying to write it. I think Todd kind of what I'm talking about too. Like, you know, just write a sum over faces of value dotted with the normal, or like v dot n or something, and then divide by the areas, something like that. It's there. I'm thinking about it, but it's something like that.
Oh, well, because that's in a lot of ways, isn't that what
that's doing? Yeah.
What this basically represents is 1 over the volume times the integral of the outward normals time. Yeah.
That's why I'm saying, like, just kind of like, okay, it's just writing in terms of sums and things, and like, oh, for each cell, and then if you wanted to, you could like put it like that, where Q represents that, you know, -1 represents that dot product there. And then,
okay.
Just I think there needs to be one more step, just kind of intuitively. So like, oh, okay, I see what it's doing now. For someone who's coming at this who doesn't quite have as much. It's like, okay, this is what they're doing for their. This is how they've been.
Yes, I always struggle with SimPEG documentation because of the D's and C's and M's, and if you don't work in this space, it is very cryptic. And I guess probably more people are globally used to sums and integrals and those things. So I second Joe's point.
And
Okay.
who would you think was like who's the target audience for this? Like is that I'm just kind of curious, like who are we targeting to read this? Is that somebody who's going to rewrite this code, or like just going to use this and then just want to have a rough idea?
Yeah.
I think the goal should just be like people should be able to use look at the documentation and at least understand what it was implemented. Like not necessarily the intricacies of it, just be like, okay, well, I see it's doing that operation. Okay.
Right. And if that's the case, then I think that starting with the continuous form and here's the discrete form and input size is this, output size is that. I think that's, to me, that's actually the most important part. Okay, I'm inputting number of cells and outputting number of faces, something like that.
Yeah, I mean, I think that part's pretty, useful. I mean, basically, we're approximating like a continuous operator. We're saying we want a way to evaluate the divergence of a vector function. And then we'll just say, the way we've discretized it, if you define the components of U on the faces, then you can get the divergence at cell centers. Because I don't know we need to do much beyond that, because that's all you need to implement it. And you need to know that it's sparse. You need to, it'd be nice to know that it's second order. These are all important things for implementation, but all of that stuff about like what's happening under the hood, or like those, I don't know, graduate level math details that kind of got covered in a tutorial where we bring people in and say, here's a way that we can approximate the divergence operator, and we're going to take this face minus this face. Like that's kind of been done in detail in a tutorial as like an extended learning. Right. So yeah, the other part is some of these things, like I think you have like a cell gradient operator, and then that becomes actually a little bit more complicated because now you're interacting with different cells and implementing boundary conditions and stuff. So that would be kind of, yeah, I guess I think I'm focusing more on implementation. So I guess, yeah, the implementation, the mapping, and like dimensions, and what function it's representing, what function is it discrete, what operation is it discretizing.
So let's see if I can.
Want me to stop share?
Hold on. Can I just drop an image in here somewhere? Is that okay? Oh. So what I'm thinking as far as like just showing it for this, I'm going to stop you for a second here, Devin. Just something like, I don't know, that-ish. that kind of like, because that's exactly what it's doing, right? For each cell, it's summing over all of the faces.
Well, it's one overvol, but yeah.
Well, yeah, yeah. Like to me, that looks a little bit more intuitive than the, you know, diag, like 1 over diag v times q times diag s. Like
Yeah.
I mean, this is literally exactly what the code is doing, right? Like it's doing,
Yeah,
and that's like the simplest way I can kind of think about it. And like, okay, well, that's pretty clear to me, at least. Like, okay, I see that it's doing that operation.
yeah. I mean, I guess to me, when I look at it, it doesn't look like a divergence. I know it is, but for me, I'm like, where's the derivatives?
Right.
So I think that's probably worthwhile to why kind of having that integral form def might be useful. So like you can start with the continuous form. And this is basically same as a divergence. And here's the discretized version. And you can clearly see that corresponding match in the code. So that's probably all you need to say.
Yeah, I mean, I'll put that in if we think it's useful. So maybe under the notes we just start. Okay, here's a continuous function that we want to discretize.
Or just like this is like
SimPEG has a way to turn it into this form, this discrete form. And for each cell, this is the operation that's actually being done, and it is equivalent to divergence.
Yep.
And then, I mean, once we've actually finalized the tutorials, one of the plans I had was to go back in and then actually link to those tutorials, so that if you really do want a full explanation of what's happening in pictures and things, then it'll just take you to a tutorial where we really go into easing them into what a discrete operator is.
yeah.
So
Even like just something stating like that, like just to keep people that, oh, it's the integral form of it, like that'd probably be sufficient as well. Like you don't even have to put, you might not have to put in like, oh, the whole, you know, DDX, like the sum of all that. Like, I don't know.
yeah, okay, yeah.
Just to make it clear that, you know, this is the representation that it is. Like, and then if you wanted to, you could even link to like, you know, Wikipedia's divergence page or something.
Yeah, so yes, something like that. Like here's continuous form, what we're doing, basically discretizing this. And you said the dimensions and mapping. I think that's probably enough, I guess, for as a user, I think.
And then hopefully the integral forms are not too difficult to figure out for some of the ones that interact with adjacent cells. Because like right now, the curl operator, the face divergence, the nodal gradient, those are all pretty straightforward.
The cell gradient is the one that's kind of a little bit weird. But like we never use the cell gradient itself in the finite volume operators, like to form finite volume equations.
For what?
Whenever we're forming like the PDEs with the finite volume operators, we never actually use the cell gradient operator that's defined.
Yeah, that makes complete sense. Like you're solving it on one cell and then yeah.
Like when we do that cell gradient thing, we're actually, whenever we do like a cell-centered thing like that, we use the face divergence operators.
Well, don't you? Yeah, when you're saying like cell gradient, I mean, aren't you really just calling? What was it? You're calling like the face divergence transpose plus your boundary condition.
Something.
Sort of.
Like that's one part I think I'm going to need to talk to you about, is how you cleaned up the implementation of being able to do general boundary conditions on everything, how that's being implemented.
Okay.
Yeah. Maybe there probably need some bifurcation about finite volume and finite difference. I think cell gradient is basically the finite difference operator.
Yeah, it's,
So potentially, it's an extra case, exceptional case. So you can potentially mention it.
yeah, and that one I think would probably be sufficient just to say that, oh, it's, you know, forward cell minus the backward cell divided by the difference between cell centers. That's what that is, right? Like that's what it is.
Yeah, because when I was looking at, when I was taking a brief look at it, it seemed like the phase divergence, I mean, you don't need to implement any boundary conditions. You just call the phase divergence, and the only input argument is self. And then when you had, let's say, edge divergence, then you would be calling self and supplying a boundary condition, whether or not it was Neumann or something like that. And so there, you're basically saying, okay, I need to implement, I need to provide it with some boundary conditions, because now I'm going to be interacting with locations that are outside my mesh.
And the point is
And
that
the result of that was just to, I guess, yeah, what would it be? Use nodal gradient transpose plus a piece.
right. The idea is that you're using the nodal gradient to approximate that edge, or like you're using a different transformation to get it to be in terms of the nodal gradient and then that boundary integral as well. Like only in that weak form do those equations work like that.
Yeah. Oh, but it's a little bit more interesting than that, because of like, do you factor out the mass matrix or do you keep it in?
That depends on like the PDE.
Yeah. I think that on that differential operator level, except the cell gradient, you don't have to worry about any boundary condition, I think.
No.
So you just can describe what it is, and that boundary condition is handled in an upper level when you're formulating, or when you're actually kind of formulating your system. So I think on that level, only place that you need to mention about the boundary condition is the cell gradient, which is an exceptional case.
Yeah. I guess what I need to do is that I have this property or this functionality that's not hidden, and it needs to be documented for, if it's visible to the user, I need to be able to say what it is. And yeah, that's it. So some of those details actually kind of have to be put in there. I can't just kind of like gloss over them, because I need to document what is this. So if I have a cell gradient, is that actually going to be returning a cell gradient, or is it going to be returning a mass matrix times a cell gradient?
So that one is just the cell gradient. Like all
Yeah.
those operators are what they say they are.
Okay, so that's super to know that. And you're saying that the cell gradient was actually computed with a finite difference, not a finite volume.
I'm pretty sure it wasn't. And if not, it was implemented in like, okay, it's actually like they did it. It was done like by just doing like the phase divergence transpose times the volume or something, in which case it's the same, it's equivalent to saying that it's, you know, the finite difference from forward cells. And
Yeah, well, I mean, the mass matrix is invertible. So like, I think it's diagonal. So you'd be able to basically like create it using the phase divergence transpose plus your piece with the boundary conditions, and then factor out the mass matrix to actually give you back a true cell gradient.
kind of. My point is that if you do that, like it's like divergent transpose times volume, right? Like that operator, ends up being like the same. Is it divergence transpose times volume? Then you have to divide by, you have to take the inverted maths matrix, like, which is just, what is it?
No, you have to apply the inverse of the mass matrix to the boundary conditions piece.
Right. Yeah.
So you basically you'd have it as like div transpose plus, and then you factor out the mass matrix times the boundary condition piece that you had, and that would give you the true
going
cell.
to like a negative divergence or something. Negative divergence transpose. And most of the time, it's just like that. And
Yeah, I mean,
easily,
the important thing is that at the end of the day, it's the actual cell gradient with boundary conditions of your choosing implemented. And I can leave it at that.
yeah.
And that's okay.
Yeah.
Because before things weren't necessarily factored out and it was kind of confusing, but now you made it make sense.
And if I like just be like, oh, the default cell gradient, I think we'll probably just leave as like, oh yeah, it's this, and then it has a zero Dirichlet assumption, or no, a zero Norman assumption at the end. I think the default
Yeah.
has a zero Norman assumption.
Yeah, and those details are important to put in. They're implementation details.
Yeah.
Okay. Well, it sounds like it sounds like you guys are overall pretty, let's see, I'll do this. Overall, you're pretty happy with the level of detail being provided, but we'll add something first that actually says this is the operator, the continuous operator we want to discretize, and replace this stuff with an integral form of how it's evaluated for a single cell.
Yeah, that sounds good to me.
Right, like for the for like the nodal gradient, right? It would just be like for every edge, just take the difference of the, the nodes at the boundary, and then in the direction of the edge, you have to edge direction times, I don't know, the absolute value of the difference. No.
Yeah.
Direction divided times the forward minus the backwards.
I'll figure it out.
I personally think it's great to have the code, but I wouldn't add the theory, but I wouldn't go too extreme, because you have like three classes of readers. The first one, they never read the documentation anyway, they just ask. The second one is the newbie, which is probably already overwhelmed and just wants to have an example that he can copy paste. So this is really good to have the example. And then one class is the one that goes straight to the code and looks there. So yeah, I think it's good to have some theory and then maybe a link to a paper or a book or Wikipedia, and that's probably easier to maintain as well.
Yeah, I mean, I could always put something here when the tutorials are done that says like, for a full tutorial on differential operators, like see here. Because there's already something that's really comprehensive about
within SimPEG.
Yeah, it's another, it's in discretize, but this needs to get finished before the tutorial section because it's going to link to the functions and stuff. But there's a whole thing where there's like pictures of cubes and stuff, and it gives you the indices of faces and writes that out.
But if you have this, don't you want to rather link there?
Well,
the thing is you could read this in your terminal with the question mark if you want to see then, but then the math is not easy to read because it's plain text, and if you read it on a browser anyway, and it will be just one click away.
Yeah, that's another possibility as well.
Because math looks nice on the browser, right? But then it's not good as a help string in many other IDEs.
That's why the nodes are placed at the end of the help string.
Yeah, so I guess you're saying if, well,
I think it's good. I think the size is really good. I wouldn't elaborate
yeah.
too much. I
Yeah,
think I did.
just trying to
I-
keep notes as short as possible, and I think we can do that. I think we can keep notes no longer than what it is right now.
I think I did some much longer in my code at some point, and I probably wouldn't do this today and rather put that maybe in the docs. But yeah, it's always
Okay.
because in the docs you can link from different places to there, right? And in yeah.
Devin, have you gotten used to the layout here?
Yeah, I've gotten used to the layout. I even tried to rebuild everything from scratch to get the tree mesh stuff to those docs to update, and they didn't work. That didn't happen. So I closed it all, closed everything, and then just said, what was it? The build extensions in place. And then I think I deleted the pre-existing extensions, rebuilt the extensions,
Yeah.
and redid the setup.
I think the easiest way to like do an in-place installation of a package right now is just like pip install dot like -e dot. Like that's like the easiest way to do an in-place installation.
To do what?
An in-place install. So
Yeah.
if you do it like that, you don't have to mess around with the Python path and everything. Like it just works.
Baby, you're saying doing it with pip. I don't want to do it with pip.
No, you don't download from pip. Pip is just a command that installs it. You do pip -e. No, pip install -e dot. So it will install what it finds in this directory instead of from PyPI.
And the -e means that it installs it in like editable mode or like
Yeah, when you
develop.
make changes, it updates.
Yes.
It basically links to your folder. It
Okay.
puts into the pip library a link to your folder. So it uses that.
Yeah. So it's nice because you don't have to mess around with your Python path and everything.
Oh, so pip install -e and then setup.py or
Just pip install -e dot.
dot. Is there a space between the e and the dot?
Yes.
Yes. The dot means in here.
In this current directory, yeah.
Install this thing here.
This thing, exactly. Grab whatever you find and install it for me.
Okay, I'll give that a shot.
Yeah, and if any project that has the setup properly made, then it works.
Okay, that is very useful. Yeah, so that's basically it. I have a lot of doc strings to do, but we're
It
making
looks
progress.
cool. It looks really good.
I think it's looking good.
Did you do any more comments since the first round that you did last week, Joe?
No, I don't think so. I can go through it again and look through it. But,
Oh, no worries. Yeah, I went through those and made those changes. So the things are the formatting and some of the stuff that's been corrected.
sounds good.
Yeah.
It's definitely going to be nice. Like I think this is a much better format and layout overall than it was before. So just unmanageable before to even look for anything. And like,
yeah, I didn't even know what I was looking for. I was just seeing like information. It was nuts. But this is actually quite helpful. So yeah, thanks for the feedback. This really helps.
So when is that change going to land? Because now the docs is still read to docs or not? I don't even know.
It's still read the docs, I think.
Docs,
that'll,
both discretize and
yeah.
yeah.
I mean, hopefully as soon as possible. I don't have an actual, it really just depends on how quick the review process is on it.
That's why I was hoping to get some stuff in earlier, which is like, I'm glad we were able to get that and see it. Okay, let's keep moving forward on that. Keep doing it. Looks good though.
Yeah, yeah, and when that's done, it'd be nice to do it for SimPEG. Yeah,
Yeah, it would be nice.
just yeah, it needs to be. Yeah.
The point is
So-
we'll have discretized good, and then we'll have a good reference point to go from.
Yeah,
It's also easier, right? Discretizers are more self-contained, smaller thing, right?
Yeah,
Compared to SimPEG.
can be as well. Like, I don't know. I Soggy's probably feeling the same way, but like we've worked with it enough to where it's like, well, I understand how everything's linked together. I understand like what happens when when you call something of the field, when you index the field, I see what's happening in the background. It's like I can see all these things happening, but they're just not well documented. And it's like they were better
Yeah.
so
There's-
easier.
there's still stuff in SimPEG that I don't understand. I think some of it is the fields object, just how it's. I haven't played around with that implementation of storing stuff. Yeah.
Yeah, well, there's a lot of pieces, and you use whatever you used to, and assume everything's working. That's fine. I think that's the purpose. I think you don't have to understand everything, but have a confidence about that's actually working in a certain level.
Until it doesn't.
Yeah, I mean,
Then you have to
Exactly.
start understanding it. Yeah.
I feel like if we prioritize it, we could be close in a couple of weeks.
Yeah, I think so.
I'm hoping so. Fill in all the doc strings and then do a final review, and then maybe decide on some formatting related stuff. Because I want to play with colors and things and fonts.
That sounds very fun.
Okay.
My original pass of that format was to try to make it look like the SimPEG.xyz site. As far as like fonts and colors and things.
Yeah, if there's nothing else, then I'll get to it. All right.
Cool.
Thanks again.
Have a good one, everyone.
Take care.
I'll